right, so physics is all about equations. And I think a really important part of this particular class is understanding where those equations come from. I always hated it when somebody just would throw this equation at me and say, here, use this, plug in these variables. Because that didn't mean very much to me because I didn't know why. I didn't understand where those variables came from. I didn't know how to use it. So one of the things that we do in our labs, pretty much every graph that you get, you're going to write an equation for it. Because I really want you to understand where that concept is coming from and how we derive it. So when you write an equation, most of the equations that we're going to have are going to be linear. There'll be a few curves, and we'll get to that later on, and we'll talk about that a little bit more. But let's just focus a little bit on the linear ones right now. Now, from algebra, you probably remember that this is a linear relationship. So we've got this y equals mx plus b. That's our slope form equation. This is a really nice general thing, but what we want to do in this class is really look at the variables involved. Okay, so x and y are variables, and specifically the variables that we measured in our lab. So the x variable in this case is diameter. So when we write our equation, we're going to replace this x with diameter. And we're going to replace this y with circumference. So remember, our independent variable goes on the x-axis. So whichever variable that we have down here plotted on our x-axis is going to be substituted in for this x variable. Whichever variable we have over here on our y-axis, our dependent variable, is going to be substituted in for our y in our equation. So in this case, y is the circumference. So that's going to equal our slope times our x variable, which is our diameter, plus our y-intercept. So we're plugging in the variables that actually are represented on our graph. Now, one thing to keep in mind, if you use Excel, this will be spit out for you. You'll have a y, and there'll be a number here, and there'll be a number here. That's not what I'm looking for. When we write an equation, you need to use the variables that were measured in your lab. So now we're going to plug in our slope. The great thing about Logger Pro is it gives you this, and I believe, I'm pretty sure Excel does this as well. But Logger Pro will spit this out, but it also spits it out with labels. That's going to be an important part as well. You have to label your slope. You have to label your y-intercept. So we're going to come over here, and we're just going to plug that in. So the circumference of our circle is going to be equal to our slope. Now your slope is going to go in parentheses because it has a lot of stuff to it. It has a number and it has labels. So you're going to put in your slope, centimeters per centimeter, times our x variable, which was our diameter, plus our y-intercept, which in this case was a negative, okay? That's your slope form equation. So when it says to write an equation, this is what I'm looking for. If you give me something with a y or an x in it, it's going to be wrong, okay? You need to change these to your variables. You need to label your y-intercept, and you need to label your slope. So what this equation tells us is the circumference of a circle is equal to some constant, some slope, 3.061, times the diameter of our circle, plus the initial circumference of our circle. Now, here in a minute, we're going to look at some things that tell us whether or not we have to include that, but we'll come back to that later on. But this is what our equation is looking for. Now, you've probably seen this before. Circumference is equal to 3.061 times diameter. What is this variable? What does this slope represent? It represents pi. So the circumference of a circle is equal to pi times the diameter. Something else that you may have seen is this diameter a lot of times we write it in terms of the radius. Diameter is 2r. So the circumference of a circle is equal to 2 times pi times r. So a lot of times you see it written like that. So that's where this equation comes from. Somebody went out and measured the diameter and circumference of a whole bunch of circles, found this relationship, and wrote this equation. So this is what we're going to do with a lot of our relationships. Every time we do a lab, we're going to derive those equations from the relationship between our two variables.